So there is a part B to this question. Once you get the tension in the wire, now it wants to know what's the force that the pole is putting on the beam. And we 100% should know that the pole's pushing out on the beam. It has to be. It has to be pushing out in the x direction because the tension's pulling in the x direction. And so if the pole wasn't pushing out, this whole system would move in. So we could do some of the forces in the x direction. It's not moving, so this will be 0. And going out is the pole's x component. And going in is the tension's x component. And so we can solve for the pole's x component. It's just going to be equal to the tension's x component. And the tension's x component, if we look at its triangle, is going to be cosine. So it'll be ft cos theta. So fpx is equal to ft, which we just found, 1,101.32 newtons, cos of 50 degrees. And when you punch this into your calculator, you should get 707.91 newtons. So that's the x component. Now the y component, it might be hard to predict. Is it going to be up or down? And you might say, how the heck am I supposed to know? Well, just put it in as positive, and if it works out to be positive, then it means up. And if it works out to be negative, then it means down. So do the sum of the forces in the y direction. So we have our fpy that we're not sure of. We have our fty, which we are sure of. The tension's definitely going up. We have our weight of the beam. Gravity always acts down, so negative. And the weight of the sine, again, gravity always acts down, so negative. And you're solving for fpy. So take the others over. The weight of the beam is m of the beam g. The weight of the sine is m of the sine g. And the fty will be ft. The x was cos, so this has to be sine theta. Fill in your values. The beam's mass was 22 kilograms times 9.81 meters per second squared plus 75 kilograms times 9.81 meters per second squared minus our tension was 1101.32 newtons sine of 50. Do the math. And when you do, you should get 107.91 newtons for the y. Once you have the x component and the y component, now you can find your fp. And by the way, the y worked out to be positive, which means it is indeed going up. So this is 707.91 newtons. Oops, that's supposed to be perpendicular. This is 107.91 newtons. They're both 91. And this will be your FP. And this will be your angle. So right angle triangle, square them, add them together, take the square root, and and when you do, you get an FP of 716.09 newtons. Add an angle of 8.67 degrees, and that would be CCW, counterclockwise from the beam, as opposed to clockwise, which would be down. And this is your final answer for 4B. Okay? All right, let's move to 5. 5 is a ladder. Sir Lancelot and Lady Elaine. If you know King Arthur and the Knights at the Round Table from English or from TV, you might recognize Sir Lancelot. If you don't, it's okay. You can still do the question. So Sir Lancelot is rescuing Lady Elaine from a castle by climbing a uniform ladder that is 5 meters long. So this length is 5 meters, and it's uniform, which means FG of the ladder is halfway along its length. And Lancelot weighs 180, the ladder weighs 180 newtons. So that's FG of the ladder, 180 newtons. So not the mass, the weight. And Lancelot, who I'm going to call P, either that or it'll have to be LL, weighs 800 newtons. Lancelot stops a third of the way up the ladder. The ladder is resting on a stone ledge down here at the bottom. This will be Fn of the ground. This will be friction of the ground. This will be Fn of the house. And rests against a vertical wall that is frictionless because of a layer of moss. The ladder makes an angle of 53.1 degrees. Find the normal and frictional forces at the base of the ladder. So we're looking for Fn and Fg, friction G. Okay, so some of the forces in the y direction should be 0. And in the y direction we have F normal of the ground minus Fg of the person minus Fg of the ladder. Take them over, F normal of the ground equals Fg of the person plus Fg of the ladder. Since it asks for this one, you have to fill your numbers in. The person is 800 newtons, the ladder is 180, so F normal of the ground is equal to 980 newtons. Now, if we do some of the forces in the x direction, not moving, what we get is friction on the ground minus the normal of the house is equal to 0. So it tells us that friction on the ground is equal to the normal of the house, but we don't know it. So we have to go to torque. So we do, oops. Sorry, I just turned something on. I have no idea what. We do sum of the torques equal to 0. So there's the torque from the normal of the ground, a torque from the friction on the ground, a torque from the normal of the house, torque from the ladder, a torque from the person. Okay, so we go back and look. Again, pick your pivot point down here. These two will disappear. Normal of the house will be counterclockwise, which is positive. The two weights will be clockwise, which is negative. So this one goes, positive, negative, negative. So R normal of the house, F normal of the house, sine theta normal of the house. Minus R of the ladder, Fg of the ladder, sine theta of the ladder, minus R of the person, Fg of the person, sine theta of the person. And we're looking for the normal of the house. We know everything else. So take the other two over, they become positive. R of the ladder, M of the ladder, G, sine theta of the ladder, plus R of the person, M of the person, G, sine theta of the person. And that's a plus sign. Divide by R normal of the house, sine theta normal of the house. Now fill in your numbers. R of the ladder, it told us it was a 5 meter long uniform ladder, so 2.5 meters. Oh, I didn't really need to switch this mg because it gave us fg, I forgot. It was 180 newtons. If you want it, you could divide the 180 newtons by 9.81 and then write that in here and multiply it by 9.81. But that seems like a lot of work for nothing. This angle down here is 53.1, so this angle up here should be its complement, 36.9, plus it said the person made it a third of the way up. So a third of 5. Uh-oh, what just happened? Here we go. My things just flipped around. A third of 5. So 1/3, 5 meters, 800 newtons for mg, and the angle again will be 36.9. The R normal of the house should be the full length of the ladder, so it should be 5 meters, and the angle for the house should be the 53.1. And so punch all of this into your calculator to get the answer. And when you do, you should get 267.79. 267.79 newtons. Okay, that's part A. Part B says find the coefficient of friction. So FFR equals mu Fn, so mu should equal FFR over Fn. So your